Hi students, this is Dr. R. Balaji, Physics faculty. Here I would like to give a lecture on Maxwell equations. In this video, I explain about Gauss law in electrostatics. Gauss law of electrostatics is defined as the total flux enclosed on the Gaussian surface is equal to 1 by epsilon times of the total charge on the Gaussian surface. Now what is meant by Gaussian surface? So this is the surface. On that surface at every point the electric field intensity remains constant. Such a type of surface is known as Gaussian surface. Okay, now what is flux? What is total flux? Total flux can be written as E bar dot ds bar. So the total flux enclosed on the Gaussian surface is equal to 1 by epsilon times of the charge on the Gaussian surface. This is called Gauss law. Now the proof. Let us consider an arbitrary surface. Say here the point there is a charge plus q, and consider a small surface element ds in that surface, and this is the normal vector. Say this point is p, and this is the electric field vector E. The angle between these two is theta. Now what is the value of E on n cap? That can be represented as E bar dot n cap, right? Now what is the value of this? What is the flux? What is the value of E bar dot n cap for entire surface element? Then you can represent it as E bar dot n cap into ds. This is equal to E bar dot ds bar. This is the flux coming from the surface element ds, right? Let us consider here there is a charge plus 1. The distance between the point P and the charge Q is R. According to our electric field intensity definition, E is equal to 1 by 4 pi epsilon naught Q by R square. This is the expression for electric field intensity. What is flux? E bar dot ds bar. This is called the flux coming from the surface element ds. This can be written as EDS cos theta. A bar dot B bar is equal to AB cos theta. Now this can be written as Q by 4 pi epsilon naught d cos theta ds cos theta by r square. This is called flux. Now here ds cos theta by r square is called a solid angle which is made at a point Q due to the surface element ds. The surface element ds, it makes some solid angle at a point Q. This is called d omega. Now ds cos theta by r square is equal to omega is solid angle due to surface element ds. Now the flux can be written as flux is equal to Q by 4 pi epsilon naught d omega, right? What is the total flux? So total flux is Q by 4 pi epsilon naught double integral d omega. In case of two-dimensional picture like circle, the total angle is 360. When you consider instead of circle sphere, this is a three-dimensional picture, then the solid angle of that sphere you can represent it as 4 pi. So the total solid angle on the entire closed surface you can call it as 4 pi. So substitute that value in above equation. We get Q by 4 pi epsilon naught into 4 pi. This 4 pi cancelled. We get total flux is equal to Q by epsilon naught. This is the proof of Gauss law. Now the differential form of Gauss law. How to represent the Gauss law in what is Gauss law? Double integral E bar dot ds bar is equal to 1 by epsilon times of Q. This is double integral, not triple integral. This is double integral. Right. Let us consider rho is a charge density. Charge density can be defined as the charge on volume element dV. So charge density is nothing but dq by dV. When you take this side, dq is equal to rho into dV. What is the charge on entire volume? Then you can represent it as q is equal to triple integral rho dV. So this expression can be written as E bar dot ds bar 1 by epsilon naught. What is the q value? Triple integral rho dV. Now, according to Gauss divergence theorem, this double integral E bar dot ds bar can be written as triple integral div E dot ds. This value is equal to 1 by epsilon naught triple integral rho dV. At arbitrary conditions, you can eliminate triple integrals on both sides. Then the above equation can be written as div E is equal to rho by epsilon naught, or del dot E is equal to rho by epsilon naught. Del dot E is equal to rho by epsilon naught. This is double integral. So this is the differential form of Gauss law, and this is the Maxwell relation. So the Maxwell first relation is nothing but Gauss law of electrostatics. The Maxwell first relation differential form is del dot E is equal to rho by epsilon naught, and integral form is this one. Double integral E bar dot ds bar is equal to 1 by epsilon naught triple integral rho into dV. Thank you.